Greetings to everybody in here. This is Martin Hedges from Neotech, Managing Director based in Nuremberg, Germany, and the Neotech experts in 3D printed electronics. And now, Martin, go for it. 5 minutes are yours.
Thank you very much for the introduction there. So you've already told everyone where we're from. So Neotech, we're a machine tool manufacturer focused on 3D print electronics. We deliver multi-tool 5-axis print systems for the automated production of mechatronic systems. And we've got two basic process routes that we use for that. So one is like printing on existing substrates. So you take an injection molded component or a composite component or something produced by traditional manufacturing technology, and then we print electronics onto the outside of that. We do pick and place. We put surface mount devices onto that, and we do that across a number of different industries. So things like example here of an antenna from Internet of Things. That's sort of a near space helium balloon kind of going up into near space with this antenna printing in, and that's the final device. We work in automotive, different applications there, from sensors, heaters, across medical, wearables, all sorts of different applications. So there that route one, we're printing on existing structures. And then we also have a second route, which we call fully additive manufacture, where we're combining the 3D printed electronics technology with classical printed electronics. So you can see in the video here what we're doing. We're actually starting with nothing, and we're basically building up, in this particular case, using classical FFF printing from a filament or from pellet extruder, build up a mechanical structure, put electronics onto that printer circuitry. Then we do pick and place, which you can see working now, placing those components. So just in the standard way, but using the 5-axis range of motion, and just basically rinse and repeat. And you start again with nothing, and you build the entire thing. So mechanical structure, your circuitry, any printed components there, plus your placement of surface mount devices. And we're now just having the first initial steps into also putting optical components into that as well. So this video basically shows up building different layers, and I'll just accelerate that so you can see at the end. And at the end we're putting, this is printing a transparent material as a waveguide. It's a very simple optical components. So that's the final device. Other concepts that we're working on, looking at automated recycling, simplifying the materials mix using these techniques. So we've got here in the center, a fully additive, printed component. We have a body plus surface mount device plus circuitry to make the mechatronic devices. We also do something similar, very early days still, working with ceramics. So printing, dispensing, in this case, a ceramic material, putting electronics inside and outside. So that's basically what we do today. And I thought I'd do something a little bit different for the second slide. I've only got 5 minutes, so I thought I'd look a little bit into the future to say, where I think we're going to be in 3 to 5 years. So I think, within that timeline, we will have the first fully automated processing lines. So that means a complete automated manufacture of mechatronic devices. That's going to be agile. We're working digitally. This is actually being driven by a big EU project that we've got on called Ampere. There is a link down there, the Penta Eureka EU project overview. If you look there, you can find Ampere. Those systems will also have some level of AI machine learning in them. Basically, in the first instance, we're looking at automated quality assurance with potential automated correction of any defects during the printing process. That's actually being driven by a German BMBF project, so a federal German project called CAM-EL. And then I think I showed in the video that we're putting different functionalities in there, but I think the functionality range is going to increase, also going into more power electronics type applications, actually putting many amps of material through things, putting optics in there, further developments in the printing field, helping us work on miniaturization, but also going on the other direction, actually printing on very, very large components. So I think we'll see a 3 to 5 year timeline for 3D printed electronics going across much wider adoption in many end uses, end cases in different industries. And I think in a 5 to 10 year timeline, I think there is potential there really for 3D printed electronics to actually completely change product architectures. We're going to go away from the classical PCB, wet chemical processing, all the waste and the filth that's associated with those. I think we're also going to see some developments, some significant developments in sustainable 3D printed electronics, really looking at resource-efficient manufacture, reduced materials mix, automated recycling, but also potentially repair and possibly also reuse. So with that last sentence, just as a little bit of a teaser there, I'd like to thank you very much for attention. Please do come and visit us in exhibition room number 8. Thank you very much.